Today, we're jumping into the story of the Lakhra Power Plant. This was Pakistan's first really big attempt to make electricity from its own coal, which is notoriously difficult to use. It's a story all about national ambition, a huge technological gamble, and a legacy that's way more complicated than just success or failure.
Yeah, this quote just nails it, right? This thing wasn't just another power station. Nope, it was a symbol. It was a bold bet on self-reliance, a massive plan to use a really challenging local resource to power the entire country's future.
All right, so to really get why this plant was such a big deal, we got to rewind the clock to the 1980s. See, Pakistan was smack in the middle of a classic problem, one that a lot of developing nations know all too well.
The choice they were facing was pretty stark. On one side, you've got expensive imported fuel that just drains your money and makes you dependent on other countries. And on the other side, huge, completely untapped coal reserves, literally right under your feet. At the time, the choice seemed like a no-brainer.
And the solution they came up with? It was just brilliantly simple. Why on earth would you haul a super heavy, low-quality fuel for hundreds of kilometers? The idea was, let's just build the power plant right at the mouth of the mine. You dig up the coal, and you burn it right there on the spot. It was a genius move to try and create truly cheap, homegrown energy.
But, of course, there was a catch, and it was a big one. It was the coal itself. This wasn't the good stuff you could just toss into any old furnace. Taming this dirty coal was going to take some serious, next-level innovation.
So the coal they were dealing with is called lignite, and honestly, you can think of it as the problem child of the coal family. It's wet, it's crumbly, and it is packed with sulfur. And that sulfur, when you burn it, becomes incredibly corrosive. We're talking it literally eats through metal. So yeah, a normal power plant was just not an option.
The answer was a piece of technology called fluidized bed combustion, or FBC. This was the magic key that could unlock all of Lakhra's potential. An FBC boiler basically creates this bubbling, super hot bed of sand-like stuff that can burn junky fuels like lignite really efficiently. And the best part? You can just mix limestone right into it, and that limestone grabs the corrosive sulfur before it can do any damage. It was the exact high-tech fix they needed.
Okay, so they had their solution, and things started moving fast. The project gets the green light in '85. By 1989, they're breaking ground with a super important partner, China's Dongfeng Electric. And by early '96, all three of their 50-megawatt units are fired up and pumping electricity into the grid. The dream was real.
But this is where the story takes a turn. As soon as the plant was up and running, the very fuel that was supposed to be its salvation started to fight back. And the struggle against Lakhra's dirty coal was really just getting started. Even with that fancy FBC technology, the sheer amount of sulfur in that coal was just relentless. It was eating the boilers from the inside out, causing all these leaks. The plant was constantly being shut down for emergency repairs, which meant its power supply was totally unreliable. And all the while, the aging equipment was struggling to keep pollution under control. And you can really see the impact in the numbers. It's pretty stark. Each one of those units was supposed to crank out 50 megawatts, but because of all the technical problems, they were lucky if they even hit 30. The plant was just consistently, dramatically limping along. If you want just one number to really capture how bad things got, this is it. A 2021 audit found the plant's real-world efficiency was a shocking 17.6%. So to put that in perspective for you, it's like for every 5 shovels of coal you threw into the furnace, the energy from more than 4 of them was just gone, wasted. It was incredibly inefficient. All this constant struggle, well, it led to a pretty inevitable conclusion. The plant today is kind of an aging pioneer, a relic from another time that's facing a really uncertain future.
Yeah, eventually the government just had to call it what it was. They officially stamped it with the label high cost and low efficiency, which is basically a polite way of saying this isn't working. And that's when you saw staff getting moved to other projects and this cloud just hung over the whole place. The writing was on the wall.
Which brings us to the big dilemma. What do you do with a massive piece of infrastructure like this? Do you pour a ton of money into trying to fix its unique old tech, or do you just cut your losses, tear it down, and start over? That's the really tough question that policymakers are wrestling with right now. But hold on, if we stop the story right there, we'd be missing the most fascinating part. Because, and you might not believe this, despite all its problems, Lakhra left behind a powerful and surprisingly positive legacy. Okay, so you can really break Lakhra's legacy into 3 big pieces.
First, and this is huge, it was the ultimate proof of concept. It showed everybody that, yes, you can actually make electricity from Pakistan's tricky local coal. Second, it basically became the country's best university for coal power engineers. And third, it single-handedly built a local economy from scratch, supporting thousands of families in the process.
And this is the kicker. This is where the story really comes full circle. Right now, Pakistan is developing these enormous new coal projects at a place called Thar, where the coal is much, much better quality. And guess who's running the show? The very same engineers who cut their teeth on all the difficult, frustrating, and ultimately educational problems at the Lakhra plant. It was like the ultimate school of hard knocks, and it prepared them for a much bigger stage.
So we're left with this really fascinating question at the end of it all. On paper, Lakhra was a technical failure. It didn't deliver the cheap, reliable power it promised. But when you see how it proved a concept, built an entire skilled workforce, and paved the way for a better energy future, you really have to ask yourself, can a project that fails on paper still be a massive victory for a nation in the long run?